Welcome back, and we're going to work on more practice with mean value theorem. So you will need your calculator, writing utensil, paper to work these questions out. So quick review for the mean value theorem. You have a few necessities. You need to make sure that the conditions are met, continuous on the closed, differentiable on the open, and if those cases exist, then there's definitely a C within these x values where the average rate of change, the slope between those two x values, is equal to the instantaneous rate of change right here. Okay, now we're just going to go into some practice problems, and it says here the function f and g are continuous and differentiable, and then they give you h. So this is h. Okay, and we have the table below gives the values of the functions, explain why there must be some sort of t in 1 to 4 such that its derivative is 3. So now keep in mind that they're saying they're taking h and they're talking about h prime, and they're saying the value has to be in between. So it could be your brain may go to intermediate value theorem or mean value theorem, but because of the going from function to derivative, your brain should think mean value theorem. And you should state that. If you don't state it, they are taking off points now, where they didn't used to if you described it well enough. So I think they're getting all nutso about that, so make sure you state it, okay? So, let's say, so you can say mean value theorem, mean value theorem, okay? Mean value theorem says, or according to the mean value theorem, whatever, that since and we're talking between these two values, they're very specific about it. And you have to show that the slope is going to be 3. So I'm going to need to figure out what we're talking about. Let's think about that first. Hold on. So I know that it has to do with the slope, so I'm going to look into that. So I know that the mean value theorem says that since h is continuous on the interval of 1 to 4 and differentiable on the interval of 1 to 4 in parentheses, then there is a C, they said T, let's change it to T, in such that h prime of t is equal to 3. Well, since we're using the mean value theorem, I'm not going to write that. I'm going to write is equal to, and let's use the formula. H of 4 minus h of 1 over 4 minus 1. That's average rate of change. And what we're going to show, and you can state this, let them know, you need to show that h of 4 minus h of 1 is equal to 4 minus 1. Okay? And we'll work that out. And we're going to say that this is going to equal to 3. So let's find that. Now, before I get into it, it says that it's continuous and differentiable. How can we be sure? They said f and g are. It doesn't say h. If you want to be super thorough, you should say h is composed of that are continuous and differentiable for all numbers. Therefore, h is also continuous and differentiable. This may be overkill. It's an overkill that I would utilize if you have extra time, but not necessary. I would just do it for the be on the safe side. So whatever. Okay, so h of 4. Let's find out what that is. So tell me. Let's work out this whole h of 4. You're gonna think about that for me. So I'm gonna go on the side here and be like, okay, so h of 4 here is equal to, now plug it into what you see here. You see what this is. Let's focus back on that. Okay, and so I'm going to be looking at that. So that's going to be equal to f of g of 4 minus, and I put 4 in that spot. So now, what is this equal to? That's right. G of 4 is 2 minus 4 here, right? So f of 2 now. F of 2 is 8. So 8 minus 4 is 4. So h of 4 is 4. Let's work out h of 1. So that's f of g of 1 minus 1. So f of g of 1 is, g of 1 is 3 minus that, and f of 3. So f of 3 is 4. Wait, is that negative 4 or 4? Oops, that's negative 4. So that's 4 minus 1. So it's 5. So h of 1 is 5. So let's show that this works. H of 4 minus h of 1 over 4 minus 1. H of 4 is 4 minus 1 over 3. This doesn't equal. I did something wrong. G of 1 is 3 and f of 3 is, I said negative 4. I forgot to put the little number 4. So then this is negative. Yeah, that would have been wrong anyway. It's funny. So that's going to be negative 5. Right, sorry. Negative 5. Great. That works now. So that's 9 over 3. So that's 3. So you've shown it. Let's move on. Okay, so next here, read it. Amusement park has this interval 0 to 45 seconds. They give you the velocity. They give you the acceleration. Okay. For a ride that does this, it's going to be continuous and differentiable, because imagine a amusement park ride that was not continuous. That would be I would not want to be on any ride that is not continuous, on a track that is not continuous. And maybe, well, I know we're talking about the length, not necessarily velocity and acceleration. My imagination went wild. Okay. Let's get started with this problem. Okay. So now, from 0 to 45, does there seem to be a time when the vehicle has no acceleration? That would mean, so no acceleration would mean that A is equal to 0. Now, if you focus solely on A, remember, the intermediate value theorem just looks at one function. It's not of the derivative as well. So if you just look at A, I can try intermediate value theorem, which would mean it has to be continuous, and that's it. But all you need for the intermediate value theorem is we need to know, is there any time in this interval that A is equal to 0? And I don't see any indication of that. You know, the velocity is going up, then it's going down. I'm sorry, the acceleration is going down, but then it goes back up. But we don't know that it ever gets negative. So if it was any of these were negative, we could have just been done with intermediate value theorem, and we would have been done with it. But there are no negatives to show, no negative to show, no negative in A of t to show sign change. So since we cannot show that sign change, we cannot use intermediate value theorem. So that brings us back to needing to use this other one. We're going to need to use the velocity and its derivative. Okay? So we're going to use mean value theorem on v of t, and that will give us information of v prime of t, which is equal to a. So I'm going to just go over the theorem real quick. we have to find a value where you need to find where the slope is going to be 0. So remember that that's what we're looking for. We're looking for, you know, I want to make that different colors. So sorry. We're looking for when that A will equal 0. So we're looking for when the slope of V will be 0. So the slope of V will be 0. That means if I do V of something minus V of something else, like this B and this A and this B and this minus A, this needs to be 0. The top must be 0 here because 0 over any number is 0. So if I subtract those y values, I have to get 0. Do you see any of them? Now look for the y values of V, that when you plug into V, you are getting 0. So if I do you see it? I see one case. I almost thought I had one. I almost thought these two, but if I subtract those two, those aren't the same. But I look at these, like that one, negative 6.2 is again negative 6.2. If I subtract those two values, that's going to be 0. And so the values of interest here are 10 and 25. Now, if you started to do a mean value theorem with 0 and 45, the problem with 0 and 45 is that these two numbers, these two y values, well, they're not going to give you 0. So if you subtract them, so it won't help. So you can kind of go through that process to see that and just had to narrow in and be like, well, it has to be these two. So use mean value theorem. So I'm going to say to you, since we're doing this, I'm going to say, so since V is continuous on the interval of 10 to 25, and V is differentiable on the interval of 10 to 25, there is a, do they give you a certain letter they want you to find? T, yes. There is a T in 0 to 25 where V prime of T, which means A of T, is equal to 0, nope, I don't want to say 0, is equal to V of 25 minus V of 10 over, oh, I just realized that's a 10, 25 minus 10. And that this is equal to 0. All right? So at 25, it's negative 6.2 minus negative 6.2 over 25 minus 10 is 15. That equals 0 over 15, which is equal to 0. Done. Okay? So that was a little thought, because, like I said, you might end up doing it from 0 to 45, and that wouldn't have helped you. So you had to think a little more, and you have time to think and figure that out. Well, why isn't this working? You know the mean value theorem. You have to push and think, okay? No giving up. Next one. Okay. It's twice differentiable. Great. So they give you this function. Great. Show that h prime equaling h prime of negative 1 is equal to h prime. Okay, let's focus on that. Let's just get that done. I'm not even going to read the rest. If they're asking me to show that, I'm just going to do that. Then I'll read the rest. I'm going to find out what that is. And then I'm going to find out what that is. All right. So in order to do that, I'm going to hold off on that side, and I'm just going to take this. And then and before you don't start plugging you don't start plugging this in. First, you have to get h prime of x. Notice I don't have a number here. If you put a number here, you may end up writing a wrong line. So you just have to find h prime first. So g prime copy what's inside times the derivative of what's inside. That's right, it's chain rule. So h prime of, we'll do -1 first, is equal to g prime of g of -1 times g prime of -1. So we're going to work out this inside first, and that's g prime of g of -1. Well, that's just up here. See that? That's 9 times, but I'm still have to get g prime of it, right? And then it says g prime of -1. Do they give me that one? No. Well, let's see. G of -1 is this. Find the function such that this and show the results. Okay, so we're gonna find out that they're equal. So I'm gonna just do this. I'm just gonna leave it like that for now. Okay, so it says here. So h prime of -1 is equal to g prime of 9 times g prime of -1. Great. I have g of 9, but I don't have g prime of 9. So I'm going to hold off and go on this side. So now h prime of 9. H prime of 9, oops, I'm going to use, well, no, that's not an oops. I'm just going to use what I have of h prime. This is what I'm going to be looking at. So that's g prime of g of 9 times g prime of 9. Because I don't know what else to do with this. I'm like stuck. I'm looking at it. I'm like, where do I go with that? So I'm going back to, so I just started to go on this one. And now that I started to do it, I'm starting to see, aha, I see where they're going with this. Tricky little guys. I see that this here happens to be exactly the same of that, just reversed. Right? Because g of 9 is -1. So this is g prime of -1 times g prime of 9. So they're exactly, oops, I'll make this go like that. They're exactly the same because multiplication is commutative. You can switch them back and forth and they're the same. So these are equal. So I ended up writing this out for no reason. Therefore, I'm going to make this neater. And I'm just going to go like this. And I'm going to say h prime of -1 equals h prime of 9. I showed it. I didn't need to write this. Good to go. Great. Let's see what the next question is. All right, so that one's done. So now it says, now use your results to show why there must be a c value in here such that the second derivative is equal to 0. So you can see that it has to be, it's some sort of like it's equaling some value, and it's the derivative of h prime. So you're going from h prime to h double prime. So we're talking about a derivative, so it's mean value theorem. So mean value theorem, and you state it, says that, and we're just writing the theorem down. So we're talking about h prime, that since h prime is continuous on the interval of -1 to 9, and h prime is differentiable on the interval of -1 to 9 soft parentheses, then there must be a C, they use C, right? They did. For -1C to 9, where since we're talking about H prime, the derivative of that is H double prime of C is equal to, and let's use that formula, H prime of 9 minus H prime of -1 over 9 minus -1. So yeah, the bottom is 10, but we already showed these two are the same, so this is equal to 0 is equal to 0. Okay? You wrote the initial, like what the conditions, and you wrote the slope. They like to see that. We're good to go. Okay, now for this last question, you will need your calculator, so please take a moment, type that in your calculator under, since we're using I'm going to be using the HP prime, type it under F1x. Now let's examine the situation. You have a point P and a point Q, and they're asking you to find, and this is on the y-axis, so you know that this coordinate is something 0. This is on the x-axis, so you know this something, my apologies, you know that this is 0 something, and then this is, here is going to be something 0. Okay, so that's interesting. Okay, fine, and it says find the C that guarantees, find the C value that guaranteed by the mean value theorem such that that it's between 0 and Q. Okay, so let's do this. So, according, so, you know, mean value theorem, I always want to write it even if they already said it. Since, you got to give the conditions, F is continuous, that says U, on the interval of 0 to Q, those are x values, and F is differentiable on 0 to Q. There must be a C in 0 to Q where F prime of C is equal to F of Q minus F of 0 over Q minus 0. Okay, so we're going to have to figure out what these coordinates are because this is a slope between these two coordinates. I mean, I do know what F of Q is, that's 0, but I don't know what F of 0 is. So let's put it, we have it in our calculator. I typed it in so I can look at it, and let's plot it. So I plot it. Here it is. That looks like it. Great. Now, this coordinate up here, I can just, the one that's by the y-axis, can you see where little spider is? It looks like it's 0, 2, but I'm just going to go to my numbers, and I see, yeah, definitely 0, 2, so that takes care of that. Now I go back to this, and I got to find what this value is. So I just go near it, press menu, function, root. I write that number down, but if you know you're going to need that number at some point, you might as well just go to the home screen, just go to home, and just press X, like, and hit enter. And then you will see that that's that number again. So I would recommend storing it since that's number is supposed to be Q. Stow is right above alpha. So, but you have to press the shift key. So you press shift, stow, right? And then I'm going to just call it Q. So I'm going to do alpha. Is alpha on? Yeah, alpha, Q. Enter. So now Q refers to that value. Great. So now let's go back. Okay, great. All right, so now I'm going to plug these into my fraction here. I have this is 0 minus 2 over that Q value. I'll just put Q minus 0. So this is F f prime c is equal to negative 2 over the q value. So great, I got to find when the derivative equals that. So I can get the derivative by hand if I want to, but this is a calculator section and they expect you to use your calculator and know your calculator skills. So I am going to go back to my h prime. I'm going to go back to my apps, go back to here. I already have it in here. I need the graph of that. So I'm going to go here and I'm going to say derivative of f1. So f is alpha f1 parentheses. I'm saying it's a function, so I'm putting that in parentheses to make that clear. And I want it for all x values. Okay, and what this will do is it will graph that. Notice I unchecked that top one because I don't want to see both graphs. I just want the graph of this function. So if I graph that, there's my derivative graph, right? I'm going to go back. I'm going to say, okay, now I want to find the intersection of that with, what was it? 2 over q, negative 2 over q, I believe, right? So it is. So negative 2 divided by, and I have alpha q, enter, right? So now I go to plot, and I see that there are 2 times, but I remember where q was. Q was about 1.5 something. So if I start pressing here, I know like that's like 1.6. So I'm sorry, yeah, that's like 1.3. So 1.5, whatever, that's like around here, I guess, right? So the intersections that I'm finding, I'm going to write both of them down. So I'm going to go intersection, function, intersection. Yep. And, oh, I needed to be near there, sorry. Function, intersection, enter, okay? There's one of them. That's 1.42 whatever. So I'm going to write that down, 1.42705. That's one of them. And why do I count that one is because it's between 0 and q. So let's find this other one. Function, intersection, okay, and there's the other one, that's 0.4762 whatever. Now there's others over here I see, but that's way out of the range. The range was only be between 0 and 1.5, so that's that. So I'm going to go back to my PDF and I am going to say that there are 2, find the C value guaranteed. So C is equal to, oh, I wrote it down, 0.476 and 1.427, if I read that correctly, right? As long as it's 3 or more decimal places, give less and they will take off points. So these are the 2 C values that guarantee that the slope will be the same. And what that means is this slope that you have here, gosh, I want to draw a straight line. I'm going to try. This slope here, which is negative whatever that is, there are 2 times that the derivative is equal to that. So one of them's around here and the other one's around here somehow. So I guess because they're changing concavity, we're finding 2 of them, all right? Or it's probably closer to here, but that's it. All right. Have a nice day.